Hello everyone, today I'm going to talk about the polar vortex, a term that has gained significant attention in recent years, especially during the winter months. This presentation will cover what the polar vortex is, how it behaves and its effects on the winter weather, particularly in North America and Europe. By the end of this presentation you'll have a clear understanding of why we experience those intense cold snaps and how they relate to the polar vortex. The polar vortex is essentially a large, persistent area of low pressure and cold air that circulates the atmosphere above the poles, both in the northern and southern hemisphere. The circulation of air flows counterclockwise in the northern hemisphere, which is the primary focus of this presentation. While it exists throughout the year, we mostly hear about it in the winter because that's when it tends to expand and influence weather patterns in regions far from the poles, leading to extreme cold events. The polar vortex is a multi-layered system that stretches from the troposphere, which is the lowest layer of the atmosphere, into the stratosphere, where the ozone layer is located. Under normal circumstances, this vortex is tightly confined near the poles, circulating at very high speeds and acting like a barrier that keeps the cold air locked in over the polar region. However, when the vortex weakens, it can become distorted and portions of the cold air mass can break off, leading to frigid conditions experienced in more temperate regions. The polar vortex is most robust during winter, driven by the stark temperature contrasts between the cold polar regions and the warmer mid-latitudes. In summer, as the temperature difference reduces, the vortex weakens and contracts, reducing its influence on the weather. It is important to note that during the winter months, the vortex can become unstable, and this instability is what leads to cold air masses spilling out into the lower latitudes, causing extreme winter weather far from the poles. One of the main triggers of polar vortex disruptions is a phenomenon known as sudden stratospheric warming, or SSW. During an SSW event, the temperature in the stratosphere can increase by up to 50 degrees Celsius within just a few days. This rapid warming weakens the polar vortex, sometimes even causing it to split apart. Another factor is the interaction with the jet streams, particularly the polar jet stream. When the jet stream is disturbed, often by factors like oceanic patterns or even mountain ranges, it can push and pull on the polar vortex, leading to distortions. Lastly, large-scale atmospheric wave patterns, also known as Rossby waves, can transfer energy from the lower atmosphere into the stratosphere, disrupting the polar vortex and causing it to wobble or break apart. When the polar vortex is disrupted and cold air moves southwards, it can lead to what's known as cold air outbreaks. These outbreaks can cause temperatures to plummet well below average, sometimes 20 or 30 degrees Celsius. In addition to cold temperatures, these events can increase the likelihood of heavy snowstorms, particularly when the cold air interacts with moist air masses. This combination often results in significant snowfall and blizzard conditions. Furthermore, when the polar vortex is weakened, these cold conditions can persist for extended periods, leading to longer and more severe winter season than usual. This has implications not only for daily life, but also for energy consumption, agriculture and infrastructure. Let's look at some notable events caused by disruptions in the polar vortex. The 2014 North American cold wave is one of the most significant, where temperatures in the Midwest dropped to record lows, with some places experiencing wind chills as low as minus 50 degrees Celsius. In 2019, another severe polar vortex event brought dangerously cold temperatures to the Midwest and parts of Canada, with some regions recording temperatures lower than those at the North Pole. Europe has also experienced the effects of the polar vortex, most notably during the 2018 cold snap, which was referred to as the Beast from the East. This event brought heavy snowfall and extreme cold to much of Europe, severely disrupting daily life. There's ongoing debate amongst scientists about the connection between climate change and the polar vortex. Some studies suggest that as the Arctic warms, the temperature difference between the poles and the equator is decreasing, which might be making the polar vortex more unstable and prone to disruptions. This concept is tied to the idea of Arctic amplification, where the Arctic ice is warming faster than the rest of the planet. This could potentially lead to a weaker polar vortex and more frequent cold air outbreaks. However, it's important to note that this is an area of active research and there is still much we don't fully understand about how global warming will impact the polar vortex in the future. Given the potentially severe impacts of polar vortex events, it's important to be prepared. One of the best ways to do this is to stay informed by monitoring weather reports, especially during the winter months when the polar vortex is most likely to cause disruptions. Ensuring that homes are well insulated is crucial for keeping heating costs down and maintaining a comfortable living environment during extreme cold. This can include sealing drafts, adding insulation to attics, and using weather stripping around doors and windows. Additionally, having an emergency kit prepared with essential items such as non-perishable food, water, blankets and a first aid kit can be life-saving in case of power outages or if travel becomes impossible due to severe weather. There are several misconceptions about the polar vortex that I'd like to address. First, the polar vortex is not a new phenomenon. It has existed for as long as the Earth's atmosphere has, but it has only gained widespread public attention in recent years due to media coverage. Another misconception is the idea that cold weather caused by the polar vortex disproves global warming. In reality, weather and climate are different things. While weather refers to short-term atmospheric conditions, climate is the long-term average of weather patterns. A cold snap doesn't negate the overall trend of global warming. Finally, it's important to note that not every cold snap is due to a polar vortex disruption. Arctic air can move southward for various reasons, and while the polar vortex is one factor, it's not the sole cause of all cold weather events. Research into the polar vortex is ongoing, with scientists particularly interested in how Arctic warming might be affecting the stability of the polar vortex. This research is crucial for understanding whether we might see more frequent or severe polar vortex disruptions in the future. Improving forecasting models is another key area of focus. By better understanding the factors that lead to polar vortex disruptions, meteorologists can provide more accurate and timely warnings, helping people and governments prepare for extreme weather events. Lastly, understanding the broader implications of these disruptions for global climate patterns is vital. The polar vortex doesn't just affect the weather in one region, its behaviour can have ripple effects across the entire planet, influencing weather patterns far beyond the Arctic. To wrap up, the polar vortex is an integral part of our planet's atmospheric system, and while it's always present, it's during the winter months that it can have the most dramatic effect. Understanding the polar vortex helps us better prepare for its impacts and contributes to our broader understanding of how climate change might be altering global weather patterns. That concludes this presentation. I'd like to thank you for your attention.